Okay, sir. Okay, thank you.
Okay, thank you, sir.
Yes, thank you, sir.
Okay, class. In the previous class, we have discussed about different types of software, in which we have discussed about the application software and the system software. In the system software, we have discussed about the operating systems, different functions of operating systems which are performed by the operating systems. So today we will discuss about algorithm and the computer network. In the group, one of the students suggests that today you want to discuss about the algorithms and computer network. So at first, we will discuss about the algorithms. After that, in the second half, we will discuss about different network devices, what is the network and internet. Okay, the first one is the algorithm. Can anyone tell me about what is the algorithm? Any one of you? Is there any idea? Okay, no idea. So algorithm is simply a step by step way so that we can perform a specific task. So it is a sequence of steps that is used to describe to solve a particular problem. That is called an algorithm. So in the programming task, we have two phases. If there is a problem which is to be solved with the help of your computers, then this programming task or making a program, it is divided into two phases. First phase is called your problem solving phase, and second phase is called your implementation phase. Problem solving phase describes your the sequence, the steps. According to these steps, you will solve the problem. It produces an ordered sequence of the steps that describes a solution of that problem. And these steps, these ordered sequence, these definite sequence or steps, these are called your algorithms. The algorithm must be definite, a finite number of sequence. These ordered sequence that describe a solution of a particular problem. That is called your algorithm. The set of sequence, the steps, the sequence of steps that is described as an algorithm. And in the second phase, you implement a program with the help of any programming language. According to the sequence of steps, according to the particular algorithm for a given problem, you design a program with the help of any programming language. That is the second phase. So a programming task that is divided into two phases. First phase is your algorithm phase, in which you write a pseudocode or an algorithm. And in the second phase, you develop a program, you implement a program with the help of any programming sub-programming language. So in the first step, in the first phase, we will discuss the first phase. That is your problem solving phase. What are the steps in the problem solving phase? In the problem solving phase, first you produce a general algorithm. What is general algorithm? General algorithm is just for English-like language which you use in your daily life. The steps which are written in your daily everyday's language, that is called your pseudocode. At first you produce a general algorithm, that is called your pseudocode. Pseudocode is your informal language steps. It is an artificial and informal language that helps programmer to develop a particular algorithm. It is similar to your everyday language, everyday English. With the help of this pseudocode, you develop an algorithm. After developing a pseudocode, you develop an algorithm to refine the algorithm successfully to get a step-by-step detailed algorithm. Now this is close to your computer language. Pseudocode is close to your everyday language, English-like language, and algorithm is close to your computer language. For example, there is the example. The example is you have to write algorithm to determine a student final grade and indicate whether it is passed or failed. And the final grade is calculated as the average of 4 marks. For this problem, you have to write a pseudocode and an algorithm. Then how will you write a pseudocode and algorithm? There is a problem in which you have to check that the student is passed or failed by calculating the average marks, the final grade, the average marks. You have to check that whether it is passed or failed. So we will write pseudocode and algorithm for this problem. At first, we are writing a pseudocode for this. Pseudocode, in the pseudocode, that is similar to your English-like language. In the pseudocode, you can see there are 3 steps. In the first step, you have just input a set of 4 marks. You have put the value of all the 4 subjects. Then, second step, you have calculated their average by summing and dividing by 4. Just a informal language, not formal language compared to the computer system. This is called your pseudocode. It is an artificial and informal language that helps programmer to develop the algorithm. With this pseudocode, a programmer can understand that in the first step, what should he do? He will enter the marks of 4 subjects. What will we do in the next step? In the next step, he will find out the average. At first, he will sum all the marks, and after that, it will be divided by the 4 in the second step. Then he will check if the average is below 50, then it is printing that the student is failed. If it is greater than 50, then it is pass. It is the pseudocode for the problem. Because pseudocode is an artificial informal language. In the pseudocode, with the help of this pseudocode, we will write an algorithm. Algorithm is generated with the help of the pseudocode. Algorithm is developed with the help of the pseudocode. Then how will you write the algorithm for the given problem? Then we will try to write the algorithm. This is an algorithm. This is the sequence of steps according to which we will execute the program. According to the number of steps, according to these sequence of steps, the program will be developed. This is your algorithm. This is an algorithm. In the first step, you have input the marks of 4 subjects. In the pseudocode, you have write that input a set of 4 marks. According to that step, I have input M1, M2, M3, and M4. So I have declared the 4 variables M1, M2, M3, and M4. I have put the value of these 4 variables in the first step. Then in the second step, I have calculated their average by summing and dividing by 4 in the pseudocode. So here, I have find out the grade by summing all the subjects' marks, and then I have divided it by 4 in the second step. And in the next step on pseudocode, I have compared it with 50. If it is below than 50, then it is fail, otherwise pass. Then here you can see the condition. I have used a loop. If condition, I have checked if condition. If the grade marks is less than 50, then we will print that the student is failed. Else, otherwise, the student will be passed. What will be the else condition? The else condition will be the grade are greater than 50. Then at last it will be end. So this is algorithm. This is a proper way to write the step by step, and it is very close to your computer language, the algorithm. Okay. Then what is flowchart? Flowchart is your graphical representation. That is a graphical representation of your sequence of instructions or operations of a program. It simply shows how data flow from source documents through the computer to its final distribution to the users. It simply shows the data flow from source to the destination. It also describes the sequence of instructions. For this representation, for this graphical representations, I use different symbols to draw the flowchart because it is a graphical representation. It shows the graphical representation of sequence of your operations. So that I use different symbols that are used to draw each type of your flowchart. For every instructions, I use a symbol. So how will you draw a flowchart for the same problem? So a flowchart, it shows your logic of an algorithm, data flow. It emphasizes your individual steps and their interconnections. And it also describes the control flow from one action to the next. So we use different flowchart symbols. So these symbols are this. First symbol is your oval shape symbol. This symbol, first symbol. This symbol, the oval shape symbol, this symbol describes the beginning or end of the program. This symbol also named as the terminals because it denotes the beginning or the end of the program. The second symbol is your parallelogram. This symbol is used for input operation. If you want to give any input operation, then this input symbol, this parallelogram is used for your input value to give the input. This symbol is used. Next symbol is your rectangle symbol. This symbol is used for some process, for some operations. These operations will be your addition, subtraction, division. For such type of operations, we use the rectangle symbol. Then the next symbol that is used, that is your diamond symbol. You can see the diamond shape. This diamond shaped symbol, this is used for your looping concept, for branching. If there is a decision making, then this is used. So this diamond symbol denotes a decision or a branch to be made. If there is a condition, if then else, then you use this diamond symbol. Okay. Then next is your hybrid symbol. Okay. This symbol denotes an output operations. And for interconnection between these symbols, I use a flow line that will interconnect these symbols. And this flow line, this denotes that your direction of your logic flow of the diagram. It will describe the data flow and control flow during the program. So first oval symbol, that is your terminal symbols, that is used for your beginning and end of the program. And next is used for your input operations, that is your parallelogram. Then if there is any operations in the program, that will be formed with the rectangles. If there is a concept of looping, there is a decision or branching, then we will use the diamond shape. For output operations, we also use a hybrid. A flow line describes your logic and control flow of the program in the program. With the help of example, we will describe again. This is the example. In this example, we have also designed the pseudocode and algorithm. Now, we are trying to draw a flowchart for the same problem. In this problem, we have to find out that the student is pass or fail on the basis of their average marks. And the condition is, if the grade marks are that is less than 50, then the student is failed. If the marks are greater than 50, then it is passed. So how will you draw the flowchart for this? For this, at first, I have used the oval shape symbol. This is your terminal symbol. And you can also see that the terminal symbol is also in the end of stop. So it is called your terminals because you are using in the beginning or in the end of the flowchart. Okay, class. These are the terminal symbols, start and stop. Then you can see that there is a parallelogram in which we have input the value of 4 subjects. We have input the value of 4 subjects M1, M2, and M3 and M4. For inputting, for giving any data to the machine, I will use this symbol. Then I am doing some processing in the data. I am calculating the grade according to the summation and division. We are performing 2 operations here, the sum operations and division operations. So I used this rectangle here for the processing of the data. Now we are checking the condition. What is the condition? The condition is if the grade value is that is less than 50. So for decision, for checking the condition, I have used this diamond shape symbol, where I will use any decision making in the flow chart. I will use a diamond shape. So here I have checked the condition if the grade marks are less than 50. If it is yes, the grade marks are less than 50, then we will say that the student is failed. If the grade marks are less than 50, this condition fails. It means the marks are greater than 50. No, then we will say that the student is passed. And at the last, it will be stopped. So this is a flow chart. Okay. So in the programming, there are 2 phases. In the first phase, the problem solving phases. In the problem solving phase, we have developed an algorithm with the help of pseudocode. And in the second phase, that is your implementation phase, in the implementation phases, we will use some programming language to implement the program. After that, we have discussed about the pseudocode, what is pseudocode, and what is an algorithm. With the help of this example, now you are able to write a pseudocode as well as the algorithm. Then now you are able to write a flowchart with this. Okay. There is one more example. We are trying to discuss it also. This example is you have to write an algorithm and draw a flowchart to convert the length in feet to centimeter. So there is a problem in which you have to convert the length in feet to centimeter. So what should be the pseudocode? Pseudocode is similar to your English-like language. That is similar to your English. What will you do? At first, you will input the length in feet. Then you will calculate the length in centimeter by multiplying it with 30. After that, you will print the length in centimeter. This is the pseudocode. Then how will you write the algorithm? For algorithm, first step should just input it. After that, multiply with 30 and then print centimeter. And this will be the flow chart of this. In the first start, this is the terminal symbol. Then we have input the value. Then in the rectangle, I have processed that value. Then I have output. This is the output part. And at last I have, this is terminated. This is done. This is complete about the algorithm, flowchart, and pseudocode. There should be some characteristics of algorithm. What should be the characteristics of algorithm? Algorithm must be your deterministic. Algorithm must be finite. There should be finite number of steps in the algorithm. If algorithm doesn't have finite number of steps, then you cannot say that this is the algorithm. So if there are not finite number of steps in the algorithm, then you cannot say that this is a algorithm. The next, this characteristic is called your finiteness. This shows that your finiteness, and there must be input specified. It means the input is the data to be transferred during the computation to produce the output. So there should be at least 0 or more well-defined input in the algorithm. So there must be 0 or more well-defined inputs. And it must be your output specified also. If there is the algorithm and it is not producing anything, that it is also not an algorithm. So the output is the data that is resulting from the computation. So algorithm must have one or more well-defined outputs. And this output should match to your desired output. Then it is called an algorithm. An algorithm must be very effective also. For an algorithm to be effective, it means all those steps that are required to get the output must be feasible with the available resources. And these statements, and it should not contain any unnecessary, any redundant steps which could make the algorithm ineffective. So there must be only those type of steps that are required to get the input, the output must be more feasible. We will try to avoid the unnecessary and redundant steps to make the algorithm effective. And it must be finiteness must be, and it must be deterministic also. And the algorithm must stop eventually. You cannot say once you have run the algorithm and it is not have any terminate conditions. It is running continuously. Stopping may mean that you get the expected output or you get a response that no solution is possible. So algorithm must terminate after a finite number of steps. So algorithm should not be infinite. It must have a terminate after a definite number of steps. Then it is called your algorithm. So must be finite. And all the steps in the algorithm must be independent. So an algorithm should have step-by-step directions. This should be independent of any programming code. Suppose we have written an algorithm for a problem. The algorithm should be same for any programming languages. It should not be your programming specific. It could be such that it could be run in any of the programming language. Then it is called a good algorithm. So these are some characteristics of an algorithm. Is it clear? Is there any questions about algorithm? Is there any questions about algorithm? Algorithm part is over. If you don't have any questions, now we will discuss about the computer network. Is it clear? Okay.
Yes, sir.
Okay, now we will discuss about the computer networks, the second topic which you have sent in the message group. I'm sharing a screen. Wait a minute. Is it visible? Okay. Computer network.
Yes, sir.
Okay, Stan. Can anyone tell me about what is the goal of your computer system? In the first class, we have discussed about the goal of your computer system. The goal of the computer system was your calculation and communication. Till now, we have discussed about the calculation parts. Now we will discuss about the communication. So, with the invention of network, after the computer network, when we started to communicate different nodes between two nodes, when we started to communicate with computers, one computer to another computer, after that, the computers became faster and very powerful. The computers of power that is increasing day by day by the invention of new technologies and this interconnection characteristics with the help of computer network. Now we are able to transfer the information, to share the information at a very high speed. So in the era of your 1960-70, at that time the computer became very faster, cheaper as well as powerful and smaller in size. But there was this drastically boom change, breakthrough that enhanced the computers after implementing the network of interconnected computers. So in the year of your 1960, at the time of your 1960, at first, the Advanced Research Project Agency of the USA, Department of Defense and Research from the university and research centers, they developed a network for this agency, for this defense agency. They developed a network that is called your ARPANET. Actually, that network was designed to share the data and to processing the data over a set of particular computers that connected through the telephone and satellite links. So this was the first network which were designed at first to develop the interconnection between two networks in that time. That was called your ARPANET by the agency of USA, US agency. That is called your ARPANET. Then the internet could carry all these informations from one place to another place, one node to another network, another node. So a computer network is a group of computers that has the potential to transmit, to receive, to exchange your data. So this network can be set. This network can be set up with the help of either your cables, your wireless medias in the modern time. So in 1969, the network began to develop on the basis of your developed design in the 1960s. So in the 1961, at first, the computer network was proposed, which was the idea of your ARPANET. So there is a huge history of developing this internet network. Then what is this computer network? How will you define the computer network? So a computer network, it is simply defined as interconnection of two or more independent computers. It is simply a connection of either your two different computers or more than two computers for transferring the data from one place to another place, one location to another locations. Then you use the computer network. That is your computer network. So nowadays, this computer network is used everywhere, at your homes, schools, colleges, railway stations, your office, in your business. Everywhere you use computer network. Daily life, you use computer network for sending emails. If you want to watch any sports event, any video lectures, at now we are together with the help of Google Meet. If you want to book any rail tickets, any air tickets, any reservations, so everywhere you use computer systems. This network is used for everywhere. So we use some medium, physical medium, like cables, through which the information is exchanged, through which the information is transferred. That is called your channel. This transmission may be either it may be your analog or digital. Some channel will transfer your analog signals, some will transfer your digital signals with a specific transfer rate. That rate is called your data transfer rate. The speed of data transfer rate, the speed of data transferred or received over transmission channel, that is called your data transfer rate. The smallest unit is bits per second. You can also measure it with Mbps, Gbps, kbps, bits per second, as you discuss in your daily life. And you will talk about bandwidth also. What is the bandwidth? That is the data transfer rate that can be supported by a network. That is called the bandwidth. It is also measured in bits per second. But nowadays, how much bandwidth is provided? That is in your Gbps, in Mbps. This depends upon which type of network device is using, which type of device you have. If you have iPhone, if you have Samsung phone, Nokia, any other type of phone, this may be one factor that affect your bandwidth, which type of network device you are using, and which protocols are used, and how many number of users are connected. There are many factors which decides your bandwidth. In a network, how many users are connecting, that will also decide the bandwidth. Is there any collision or error? What is the overhead? That is also decide your bandwidth of the network. These are some basic terminology of your computer network. So next, data communication. What is the data communication? The term telecommunication means communication at a distance. You want to communicate at a distance, so that we are using computer network, because we are not in the same place. One is in one place and then another place. You are in Afghanistan, I am in India. We are communicating with each other with the help of this telecommunication. So the data refers to the information presented in whether forms agreed upon by the parties using the data. This is your telecommunication. And data communication are the exchange of data. That is the data transfer between two devices. What are these devices? These devices may be anything. They may be same device or different type of devices. That are with data transfer, data transmission, exchange of information between the devices with some form of your transmission medium. That medium may be anything. Analog, digital, with the help of cable or wireless medium. Then there are the factors. Delivery, what is the accuracy, data accurate or not, the correct destination or not, which data is transferring, that is in the real time or not, or is there any delay in the transmission. That is. Then we will discuss about the components. What are the components? So for the data communication, these are the 5 components for data communication. First component is in a message. That is also called packet. First time. For data communication, there must be a message which is traveled from one location to another location. So next, there must be a sender which will send that message to the another one. That is called your receiver. For communication, sender to receiver, there must be a medium. With the help of this medium, the data will be transferred from sender to location, sender to receiver. This medium may be your physical medium or wireless medium. With the help of this medium, the data will be transferred. And for this for this exchange of data, I use some rules and regulations. These rules or regulations to transfer the particular data, that is called your protocol. So, for communicating the data from one location to another location, there are 5 components which are required. First component is message, which is very important, which is transferred from one location to another locations. And one first party is the sender party, which will send that message, and another one where it will be received, that is called the destination as well as the receiver. And there must be a medium between the sender and receiver, the source and destination. And there are some set of rules for transferring the message. This is called your protocols. And then how the data will be flow. How the data is flow into the network. That will also be in 3 types. Either the mode of transmission can be your simplex, your half duplex or full duplex. The data in a communication system that may be transmitted either analog or digital data. That can be transferred either a single path serially or a number of parallel paths. So the data can be sent synchronously when both the source and receiver are not following the timing, or they are following the sequence when both the sender and receiver are agree on the sequence. So there are 3 modes of your data transmissions. First is your simplex mode, another is your half duplex mode, and next is your full duplex mode. In the first one, the first is simplex mode. In the simplex mode of the data communication, the data flow is unidirectional. Unidirectional means the data will travel only in one direction. You can see in the diagram. There is only one direction. Only one direction. The data is transferred in only one direction. So in the simplex mode of the data communication, the data flow is unidirectional. This means that data travels only in one direction. That is from sender to a receiver. And the receiver cannot respond back. It will not respond back to the sender in the simplex mode. In the simplex mode, it is not respond back to the sender. For example, the simplex mode is keyboard or a television station telecasting a program. Because the data is traveled only in one direction. That is not transferred in both directions in the simplex mode. The second one is your half duplex mode. In the half duplex mode, you can see the arrow in both directions. In the both directions. So in the half duplex mode, the communication occurs when data flow in the both direction. The data will be transferred in the both direction. Although in only one direction at a time. Data will be transferred in the both direction, but only one direction at a time. For example, a walkie-talkie system or a two-way radio normally by police, walkie-talkie system. In the police system, you can see the walkie-talkie. The data will be transferred only in the both direction, but one at a time. You may use the word over to indicate the end of the transmission. You have heard that. It's over. And ensure that only one party transmits at a time. both parties cannot transmit at the same time in the half duplex mode. In such systems, sender and receivers both transmit on the same frequency, such as in the walkie-talkie that is used by your police department. They are using the same frequency for transmitting the data from one location to another location, and they will send this data one at a time. The next is your full duplex mode, the third one. So in the full duplex mode of data transmission, data is transmitted in both the directions simultaneously. You can transmit the data in both the directions parallelly simultaneously. This means both the devices in the network can be send and receive the data at the same time. They can send and receive the data at the same time. For example, you can say the two-lane route with the traffic. In that, the traffic is moving in the both direction at the same time. So in this mode, signals are going in either direction, share the capacity. So half of the bandwidth is used for sending the data in one direction, and the half of the bandwidth is used for receiving the data from the other direction. For example, in your telephone conversation, when you are talking with someone in your mobile phone, then you use your full duplex mode, because half of the bandwidth is used for sending the data in one direction and half of the bandwidth is used for receiving the transmission. So a computer network requires that computers must somehow to be connected with each other. So you require a physical connection between two or more computers. So this may be through either your physical wired media or wireless media. Okay, so these are your mode of data transmission. Either it will be your simplex mode, half duplex mode, or your full duplex mode. Okay, so next is your network. What is network? So network is a set of devices. Devices, sometimes it is also called nodes in the computer network, that are connected by communication links. A node can be anything. That can be your mobile phone, that can be your computer, printer. A node can be anything that is capable of your sending or receiving the data. That is the node in the network. That is your computer network. And what types of the network should be? There are two types of connection. First connection is your point-to-point connection. Point-to-point connection is also called your dedicated connection, because it is just a link between two devices, a dedicated link only between two devices. They are connecting through a link, a dedicated link. That is the point-to-point. It is more reliable, and the bandwidth will be high because there are only two link node, a dedicated link. The another connection may be your multi-point connection. In the multi-point connection, we use many devices, more than two specific devices, to share a single link in the multi-point connections. Then how these connections are performed done? How we communicate these devices? What type of the physical connection should be? That is called your physical topology. That is your physical topology. topology describes how the computer systems are connected, how these computer networks are connected to each other. That is your computer network topology. It is simply arrangement which computer systems or network devices are connected to each other. That is your topology. A network topology is the arrangement with which computer systems or network devices are connected to each other. So topology may define your physical as well as your logical aspect of the network. So the physical topology, the logical, that could be same or different in the same network. The first topology, that is your bus topology, or in the first is your in here it is mesh topology. In the mesh topology, in this type of topology, a host is connected to one or multiple hosts. A node is connected with one or many nodes, multiple nodes. You can see that every node is connected to each other. So in this topology, you can see that there is a point-to-point connection with every other host. So every host has a point-to-point connection with every other host. So all are connected through point-to-point links in the mesh topology. So every device has a dedicated point-to-point link with every other. All devices are connected to each other. So there is a dedicated link between two devices. But there are some advantages and disadvantages for link to link, a dedicated link. Sometimes it is asked in the question paper, that objective question paper, how many number of physical links are required in a complete mesh topology? So there are n into n minus 1 by 2 physical channels to link the n devices in the mesh topology. It is very important question. If there is a point connection between two nodes, yes, who have raised hand? Yes, is there any question?
Hello, dear teacher. If
Yeah,
we
yeah.
have
Mhm.
five category topology,
You are not. You are not. I am not able to hear you. Your voice is cracking. Is there any network issue? Yes, Wahida.
uh, if we have five topology
Yeah, yeah, yeah. Now you are audible. Mm.
or no?
I'm not able to hear you. What you said? Okay. When you will able to ask, then ask me. Okay. So in the mesh topology, the maximum number of links that will be okay. Write your question here. Yeah, very good. Write your question. Yeah. So if there is a fully connected mesh topology, then there will be n into n minus 1 by 2 physical links channels with the end devices. But there must be some advantage and disadvantages for that. First disadvantage, the disadvantage will be more cables and ports are required because we are using a point-to-point connection between two nodes. For every node, there is a point-to-point dedicated link. So more cabling is required. An advantage, it is very secure, less traffic and dedicated link. More reliable. It should be more reliable. The mesh topology should be more reliable because there is a dedicated link between two. So this is highly reliable as compared to other one. In the mesh topology. So these are some advantages and disadvantages of your mesh topology. Okay. So it is first, it is fully connected, robust and not flexible. The advantages are each connection can carry its own data load. If there is a fault, it is diagnosed very easily in the mesh topology. And disadvantage of this topology is installation and configuration is very difficult because we are using more cabling, so cabling cost is also more. Bulk wiring is required in the mesh topology. Next is your star topology. What is star topology? Then we will discuss about the star topology. So star topology is, in this topology, all the computers, all the nodes are connected to a single hub, single centralized hub through a cable. This hub is the central node and all the other nodes are connected to the central node. Now central node play a very important role in this star topology because all nodes are connected or centralized with the central node. So what should be the characteristics? So every node has its own dedicated connection to the centralized node, to the center of the hub. So the advantage would be your fast performance with few nodes and low traffic, low network traffic. And hub is easily upgraded and it is easy to troubleshoot the hub. If only one node is affected, if only one node is failed in the network, the rest of the nodes can work smoothly. So all nodes are independent. If one fails, the rest of nodes will work very smoothly. But this is a disadvantage also. Suppose if the centralized node, if the hub fails, then what will happen? If the hub fails, then whole network is stopped because all the nodes are depend on the hub. And the performance of the complete network, that is purely based on the hub. That is based on the capacity of the hub. Because everything is dependent on the hub. And if hub fails, the system will be failed. This is the disadvantage of your star topology. Next is your bus topology. In the bus topology, in this type of topology, is in which every computer and network, all the devices that are connected to a single cable, a single bus, all the network devices, nodes are connected through a single cable. And it has exactly two endpoints. Then it is called your linear bus topology. It is also called a linear bus topology. So cable have one side in one end and other side another end. And we have drop lines to communicate with the nodes. But there are some limitations. It transmits data only in one direction in the bus topology. Every device is connected to a single cable. But it has some advantages also. It is very cost effective. Cable cost is very least because less number of cables are required to connect to the nodes as compared to other network topologies. It is more feasible for very small networks. And in the bus topology, it is very easy to expand joining two cables together and just join a cable in the one end and expand it. So it is very easy to understand also the bus topology. But if the cable fails, suppose the cable is failed, then what will happen? Then the whole network will fail. This will be the disadvantage. If the network traffic is heavy or nodes are more, the performance of the network decreases. If the network traffic is heavy, then the network's performance will be decreased. And cable has a limited length also. But it is slower because all nodes are connected through a single cable. That is your bus topology. Next is your ring topology. In the ring topology, as name suggests ring in the circle, it is called ring topology because it forms a ring and each computer is connected to one another. It forms a ring as each computer is connected to another computer with the last computer is connected with the first one. So exactly two neighbors for each devices. For every device, there must have your exactly two neighbors because every node is connected with its neighbor and the last node is connected with the first one. It forms a ring. So a number of repeaters are used for ring topology with large number of nodes. Suppose you want to send the data to the last node in the ring with 100 nodes, then the data will have to pass through 99 nodes to reach the 100th node. So, to prevent the data loss, we use repeaters in the network. So there is a requirement of repeaters. If you want to send to the 100th node, then you have to pass through 99 nodes. And the transmission is unidirectional. But it can also be made bidirectional. If we just have two connections between each network node, then we will call it dual ring topology. Generally, the ring topology unidirectional, but you can make it bidirectional by having two connections between each node. So in dual ring topology, two rings are performed. Now there are two network rings in the dual ring topology. the data flow is in the opposite direction in them. But if one ring fails in the dual ring topology, the second ring that will be act as a backup that will keep up the network. So the transmitting network is not affected by high traffic because we are using the repeaters also, and it's very cheap to install and expand the ring topology. But if you want to add or delete the computers in the ring topology, it will disturb the complete network activity because it is a ring. If you are removing or adding a particular computer in the ring, at that time it will disturb the total overall network activity. So troubleshooting is very difficult in the ring topology. So if there is a failure in the one computer system, then it will affect the overall computer system in the ring topology. Next topology is your tree topology. What is your tree topology? As the name suggests, how will you define a tree topology? In the tree topology, it has a root node at the top. It has a root node and all the nodes are connected to it, forming a hierarchy. All the nodes, remaining nodes are called child nodes in the hierarchical level. The top level is the root node. So it is also called your hierarchical topology. So it should at least have 3 levels to the hierarchy. It is more suitable for workstations, ideal for the workstations are located in the groups. Then you can use this in the wide area network. But in the tree topology, it is very easy to extend. If you want to extend any node, just put down in the last node, in the last time, in the lowest level, extension of bus and star topology. It is easily to manage and maintain. If we add more nodes, then maintenance will be difficult. But if the root is failed, this hub is failed, then what will happen? All the nodes are connected to it. That will be also failed. If the root is failed, then this will also be failed in the tree topology. Then hybrid topology. Hybrid topology is a combination of your all type of topology. You can make any type of combinations in the physical connections. You can take all of them, you can take any 2, any 3, according to your requirement. Then that is called your hybrid topology. All other topologies that are your hybrid topology, that are combination of 2, more, and all, that is your hybrid topology. Then different types of networks which we use in our life, day-to-day life. That are your local area network, wide area network, metropolitan area network, wireless local area network. These are different types of network. Local area to your wide area to metropolitan area. These are different types of networks which you use. Okay. At first, we will discuss about LAN. What is LAN? If the computers are located in the same room or the same floor or the same building, and that are connected to form a single network to share the data, the resources. Then we use the LAN, local area network. So LAN is generally limited to the specific geographical area less than 2 kilometers. Then we use LAN. Then we support high-speed networks. So for a small area network, we use local area network systems. Network devices such as your workstations, printers, file servers, which are normally accessed by all the other computers. Your network devices such as hubs, switch and routers, these are also used in your LAN. Your network interface carded and IC cards, these are one more component of your LAN. So it connects computers in a single building, in the single block or campus. So they work in a restricted geographical area. Actually, these are the private networks that are not subject to traffic or other regulatory or controls. So LAN operate at relatively high speed in compared to your wide area network. So it allows a high speed exchange of your data and information. But some type of security system must be implemented if it is important to protect, if you want to protect our confidential data in the LAN. The security features is low in the LAN, in wireless LAN. Then there exists a metropolitan area network, MAN, that is called your MAN, metropolitan area network. So metropolitan area network or MAN, it's a large computer network that spans your metropolitan area or a campus in a city. It's a geographic scope that is between a WAN or LAN. They typically use your wireless infrastructures or your optical fiber connections to link their sites. Such, for example, in a city, we use MAN. So a MAN is optimized for a larger geographical area than a LAN. It ranges from several blocks to building to the entire city. So MAN can also be depend on the communication channels of moderate to high data rates. It is owned or operated by a single organizations or many individuals or organizations may also use it, may also operate it, owned it by the many. So they will often provide means for internet networking of local area networks. Different local area, different local many local area networks are connected through MAN. It can span up to your 50 kilometers with the help of your network devices such as your modem, your wires and cables. The network size falls intermediate between your LAN and WAN. It covers between your 5 and 50 kilometer diameter, between 5 and 50 kilometer. So many man cover area are the size of the capacity. So generally covers your towns, your cities, that is ranging between 5 and 50 kilometer diameter. It is developed in 1980s. We generally transfer the data with the help of optical fiber cables in main. Then there's WAN, wide area network. Wide area network is a network system connecting cities, countries, or continents. A network that uses routers and public communication links, servers, proxy servers. The largest and most well-known example of the WAN is your internet. So WAN is used to connect the LANs and other type of networks together, so that users and computers in one location can communicate with another one. So WANs are built using your lease lines. So at each end of your lease line, a router connects. So a router connects the LAN to one side and a hub within the WAN on other end. This is your internet. So it generally covers a large distance, states, countries, continents, and the communication medium between your satellite, your public telephone networks, which are connected by your routers. The WAN part. The routers simply forward your transmits your packets from one end to the another end and route it from sender to the receiver. So it covers the whole earth. So computers all over the country, all the continent, the connection is made via satellite communications. That is your internet. You can see there, these are the computers which are connected in the LAN with the help of router and with physical devices. They are connected with switched LAN, WAN, after they are connected with modem and here. This is a infrastructure of a heterogeneous network that is made up with 4 WANs and 2 LANs. Then we are discussed about the internet that has changed type of your WAN, that has changed many aspects of day-to-day life. Nowadays, everyone is using internet. It has affected the way we do business as well as the way we spend our leisure time. Everyone is using internet. It is a communication system that has brought a wealth of information on your fingerprints. That is the internet. This is generally a architecture of your international interconnection of your international service providers. Then we will discuss about different types of network devices which we use in our day-to-day life. These are our network devices. The first network device, what is the network devices? A network device is a hardware or software, a piece of hardware or software that is used to communicate between a computer and an internet network. So network devices are very important. It is very important for establishing a network connection or maintaining or protecting or enhancing that connection. We use different types of network devices. With the help of these network devices, We facilitate the data transmission. We communicate between two devices. We enable the efficient and secure network connectivity. We enhance the network performance and optimize the traffic flow with the help of these devices, which are shown in the screen. We also provide the network security with the help of these devices. For the network management and configuration, network devices are also used. So there are different types of network devices which we will discuss in this lecture. The first network device, which is your NIC, that is called your network interface card, NICs. You have heard that, NIC. In NIC, network interface card, it is an internal hardware chip. It is an internal hardware chip that connects a device to the internet. It is installed inside your computer system, in your laptop, in your machine, in your node, that connects that device to the internet. So network interface card connects a device to a network, to the internet. So in an NIC, it transmits a signal that sends your information to the another layer, to the another node. So all the data passes through the NIC to the server and back to the device. So we use a network interface card that is used to connect the device to the internet. For this purpose, we use network interface card. Next, we use modems. Modem is also called your modulator and demodulator. MO stands for modulator, DM stands for your demodulator. It converts your digital signals into analog signals. The signals which we receive in the digital form, that is converted into analog signals with the help of your modems. So it converts these signals into analog signals of different frequencies and transmits them to a modem at the receiving end site, at the receiving end. So the receiving modem performs the reverse transformation. And we also provide a digital output to a device connected to the modem, usually a computer. So the digital data is usually transferred to or from the modem over a serial line. Then we use modem here. First, we use network interface card, that is the connection, a device to the internet. Then we use modulator and demodulators for converting the digital data to analog data. And after that, at the receiving end side, we have also get the digital data. One more device, network devices we use, that is called your repeaters. These are your physical devices. All the network devices are your physical devices, hardware part. So repeaters, a repeater is also an electronic device that works in your physical layer. It simply amplifies a received signal. What signal is received, it amplify that signal. It receives a signal and retransmits it at the higher level or higher power. As name repeats, it retransmits the signal It amplifies that received signal. Why it amplifies that signal? So that the signal covers the longer distance, sometimes more than 100 meters for standard length cables. For this purpose, it amplifies that received signal. So repeaters are very useful for anyone working in a large facility where the Wi-Fi might be spotty in the outer reaches of the space. In the large office buildings, warehouse, laboratories, and campuses, all locations that can benefit the repeaters. You can see in your campus, different repeaters are used. Then we also use one more network device that is called your bridge. As name suggests, bridge. Why bridge is used? Bridge is used for connecting two banks. Same here. Bridge. Bridge connects two or more host or network segments by storing or hosting frames between data. So it connects to the two different networks, two hosts, two network segments. It uses your physical address, MAC address for transferring the data. So bridge can also connect to physical LANs into a larger logical LANs. So bridge can be set up using two models. You can use two models to set up a bridge. First model is called your local bridging, or next one is called your remote bridging. Local bridging is that establishes a LAN connection with the local cables. Local bridging, local connections, LAN connections with the local cables. And remote bridging, it is the connection. It is the two connection together by wide area network. So bridge filters all the incoming data packets. So bridge makes no modification, no formatting in the current incoming data. Bridge just filters and forwards the data to the network. So bridge just connects two or more hosts or network segments. That is the role of bridge. So next device, network device, that is called your hub. Hub connects your multiple computer networking devices. Suppose you want to communicate, you want to connect 10 computers in a lab through the network, and then you also use the hub. So hub do not perform any modification, any filtering in the data. They generally send data packets to the all connected device. It is the characteristics of the hub. It simply transmit. It simply forward the data to all the. It means hubs are used for broadcasting purpose. It simply broadcasts the data which it is received to the all nodes connected to it. But a hub also acts as the repeater. What is the role of repeater? It amplifies the signals. So hub also amplifies the signals. Which type of signals? Crumble signals, retorted signals. After traveling long distance over the connected cables, the signals are crumbled. So hub amplify those signals. So a hub is the most straightforward network. that connecting device because it connects the LAN components. It can be used with the digital data as well as the analog data. So there is only one task, that is simply broadcast the data which it receives. Next is switch. Switch is also an intelligent device. It is called intelligent device switch. So a switch is a multi-port device. It also improves your network efficiency. Switch performs your routing. Switch maintains your routing. How one packet is transferred from one end to another end. So that switch is also used. So switch maintains limited routing information about nodes in the internal network. So switch generally read the hardware address of incoming packets to transmit them to the appropriate destinations. It do not broadcast the received message. It is an intelligent device. Hub simply broadcast the message to all. But switch don't do that. Switch read the hardware address of the incoming packets. It will read the hardware address of the incoming packet to transmit them to the appropriate destination. It will send it to the appropriate destination, not to all. So it is intelligent device. So there are two major type of switches. One is modular switch. Modular switch, it allows systems to expand as it needed or if the network requirements change. If there is a requirement of changing in the network, it allows the system to expand as needed. Another can be your fixed configuration switches. It have your set number of ports and it cannot be expanded. So fixed configuration switches are fixed number of ports. So they are not flexible, so that they are cheaper in comparison to your modular switches. But switches improve your network efficiency better than your hubs or your routers because of their virtual capability. With the help of this, it examines the network monitors. It boosts your network security. It is used for routing. It generally not broadcast a message to everyone. It read the hardware address. According to that address, it transmits the data to the dedicated destination, to the appropriate destination, so that switches are used. Then next divide comes into existence, that is your routers. Routers are mainly used to direct the traffic. As name says, router, it routes the path. So the main job of the router is to direct it. It will direct the traffic movement. So router transfer packets to the destinations by maintaining a path table through the interconnected networking devices that are connected using different network topologies. So it maintains a routing table so that it can transfer the data from one location to the correct destination. So routers are intelligent devices that store the information about their connected networks. So routers also divide your internal networks into two or more sub-networks, small networks, and that can be connected internally to other routers. It generally creates zones for these sub-networks. So it is an intelligent device. So routers establish a communication by maintaining routing tables. It stores all the routing information in the table so that it will able to transfer the data from one location to another locations. So establish communication by maintaining tables about your destinations and local connections. It contains all the information about the system connected to it and where it is to send the request or where if the destination is not known. Then we use different types of routers. Routers may be your static routers, your dynamic routers also. Static routers can only be configured manually and stay that until changed. And dynamic routers use information about nearby routers to build their routing tables. Then we use the dynamic routers. The next network device next is your gateway. Why we use gateway? So gateway connects network operating on different protocols. What are the protocols? These are the different rules and regulations for data transfer. So data can transfer between destinations. So this connects the networks that are operating on different protocols so that the data can be transferred between destinations. So gateways translate between networking technologies such as your different models which we use, such as your OSI model and TCP/IP model. So gateway connected two or more autonomous networks, each with its own routing algorithms, protocols, topologies. So they perform all the functions of routers. Gateway performs all the functions of your routers. So you can also see that a router with added translation functionality is called a gateway. If in the router there are more added translation functionality, then it is called a gateway. So we use these different types of network devices in our computer network. These are the different types of our network devices. And protocols are your rules and standards, set of rules which are used to which are used to transfer the data from one location to another locations. Okay. Protocols have some syntax, that is the format of the data, and it also has semantics, that is the meaning of its sections, and some timing. We have different protocol standards also. These standards are your ISO, that is your International Organization of Standardizations. One is your ITU-T, Telecommunication Union. Another standard is your NC, American National Standard Institute, IEEE and EIA. Okay, these are some protocol and standards. In the next class, we will try to discuss some network models, and we will also discuss the topics which you want to discuss in the next class. I think it's enough for today. Okay, class. In the next class, we will discuss different network models, or we will discuss about some topics which you will share in the group. We will discuss on those topics. Is there any questions?
No, sir.
If you have no questions, you may leave. Okay, dear students, we will meet in the next class. Kindly share some topics which you want to discuss with me in the next class. If any one of you have any different questions you don't want to ask and you don't want to tell me in the group, you can also message me individually. I will answer there. Okay. Okay, class. Thank you, students.
Okay, thank you, teacher. Thank you very much.
Okay, okay. Okay, you may leave.